Okay, so let me change. It is week 3. There we go. So week 3 is matrices and determinants. So I found this nice meme. I haven't created any of these. I just find these on the internet. But it says solve out matrices by hand. Ain't nobody got time for that. And that is true because I'm not making you guys do it by hand because it's true. It takes a long time. Take the whole Gaussian elimination process, and it's like that. So I don't want you. I'm going to share you with your technology to make it easier. So we're going to go through this week's material, the tasks, what you have to do for the discussion, the assignment, quiz, suggested schedule. So let's take a look at what you're doing this week. So we are looking at chapter 8. So we were in chapter 7. Now we're moving to chapter 8. We will eventually go back earlier. We're kind of skipping around in the textbook. So we're doing 4 sections in chapter 8. We're not doing everything in chapter 8. So we've got matrices and systems of equations. So that's basically making the connection between a system and a matrix. And in my video that's labeled Gaussian elimination, that one I talk about the connection there. Then we have 8.2, which is operations with matrices. So that's like adding matrices and multiplying matrices. We can subtract matrices. We don't divide matrices. That's not a thing. Then 8.3 is the inverse of a square matrix. If you have something, so a square just means that you have the same rows as columns. And if you have something that's not square, which is rectangular, you can't take an inverse. So you can only do inverse of square matrices. And then 8.4 is the determinant of a square matrix. And so that's a special value that a matrix has, and it's used for a lot of different things. So this is introduction to matrices. A lot of this is kind of similar. A matrix is similar to how information is stored on a computer. And so when you're multiplying things a different size on a computer and you have lists of different dimensions and stuff, that's actually you're working with matrices. So that's how this can connect to computer science and engineering, especially if you do any programming. So we've got your week 3 discussion, your self-assessment, the application assignment, and then the journal. So let's start with the discussion. And this discussion is very wordy. I've been trying to figure out how to make it less wordy. I've been thinking about it, like it talks about good things, but how can I condense this? So I'm going to just start by reading it out loud and then try to break it down. So explain how you see the relationship between the 3 elementary row operations performed on an augmented matrix and the operations that lead to equivalent systems of equations. So that system has, or sentence, that sentence has a lot of words. So we know the 3 elementary row operations. Those are the row operations we talked about in my 7.3 video. Interchanging rows, multiplying rows, and then adding the rows together, basically. An augmented matrix is just a matrix of a special, that looks special. And then equivalent systems of equations are just, if you do this, do you get a system that means the same thing? So that's what it's talking about. Explain the relationship between them. So I would say explain the relationship between working with a matrix and working with a system of equations. That's how I would interpret that sentence. The second sentence, what advantages do you see in converting a system of equations to an equivalent augmented matrix? So basically, what is the advantage of working with a matrix instead of a system? So we worked with systems last week. What makes matrices better? Then research a particular application of matrices, explaining how a matrix is used. So look for where matrices are used in the real world and explain how it's used in that context. Then based on what you have selected, think about the 3 operations of addition, scalar multiplication, and matrix multiplication. Can you describe what the results actually mean? Note that in some applications, some of these operations may not have meaning. If that is the case, explain why. So this is like, you take your real world situation where you're using matrices, and then what, is there a meaning behind adding them together? Is there a meaning behind multiplying one by a number? Is there a meaning between multiplying two of these matrices together? There are some real world uses where there isn't meaning to all of them. So that's what it means to, talk about a real world use, and then what are you doing matrix multiplication to do what you need to do? And what does the result mean? What does the answer mean that you're getting? There is, I believe it's question 2 on the application assignment this week, where you're kind of doing the same thing. It gives you a real world situation, and then you have to interpret what it means. So that's sort of what this discussion post is getting at, the discussion prompt is getting at as well. So there's a lot going on here. So I've tried to break it down into 4 things that I'm really looking at. So provide a real world example and applications where matrices are used. Explain why matrices are best in these situations. When you use matrices, what are your results? What are your findings? Like, what are the answers that you're getting? And then what do the matrix operations mean in this situation? What kind of information do they give you? Do they give you something useful? So that's what I'm looking for, and it might take some time to kind of break this down and kind of understand what's going on. So I would start with focusing on a real world example, because that helps you understand what these operations mean better than just looking at it and being like, okay, what does, I just did this. This means nothing to me. So that's the discussion prompt. Very wordy. Focus on my 4 bullet points, and that will help you be a little bit more successful at trying to address the prompt. And of course, you do have a minimum word count, so you want to make sure that you hit that word count. And if you do research, like you will be doing research to find real world applications, please provide the links to where you got that research. So that way other people can check those links and see, check out the information, that sort of thing. So do include your references. Are there any questions on the discussion prompt? This won't make too much sense yet. Do you just need the links or like a full-on reference? Links are fine. I really don't care if it's an APA format. If it was a formal paper, I would want APA format, but this is a discussion, so links are just fine for me. This is only a 100 level class. If it was like 300 level, like when you go to calculus, then APA would be good, because it's a higher level class, but you don't need to do that. Just links are fine here. But you do get kudos for me if you do full on, proper references, and it is good practice, but I'm not going to take off points. There are other questions? Okay, so let's talk about your assignments. And I have not gotten a chance to start grading the week 2 assignment yet. I was hoping to get to that today, but we had several meetings, so I'm hoping tomorrow I'll be able to get to that. So I don't have any immediate feedback on the assignment that I can bring forward to week 3. But so you've got only 4 problems from the reading this week. And just make sure you're getting through your reflection journal as you go through the assignment. Show all of your work. I'm going to go more into detail here. So the week 3 assignment, what to watch out for. So you need to make sure that you answer all of the questions that are asked. Because a lot of times, and I noticed this on the week 1 assignment, they'll do some math and then they don't actually answer everything that was asked for. Or you give something, but it's not what was asked for. So make sure that you're rereading what was asked for, you're doing what was asked, and then you're answering everything there. Because that's usually where people miss points. For word problems, make sure all of your answers are in context and complete sentences, so you're not just giving me numbers, but you're giving me what it means, and that's especially important if there's multiple answers because you have multiple variables. Since this week is about systems solved via matrices, so all the problems this week don't give you the system of equations. So it's like week 2 where you were not given the system. So before you create the matrix, you have to first create the system. So that means I need to see your system of equations before I see your matrix. So if you just give me the matrix, you haven't given me enough because you have to create a system and then convert that system to matrices. So I do expect to see a system of equations for problems 1, 3, and 4. Problem 2 is not one where you have to really solve that way, so you don't have to worry about that for problem 2. I do require that you need to give me the setup for each matrix for every problem. So you need to set it up, whether it's setting up the multiplication or you're setting up the solving, but you have to give me the setup. And then you need to solve using matrices. So you do not solve with elimination or substitution or the solving methods from the system of equations, because if you do that, you're not doing the matrices, which is what this week is all about. So you need to use matrices to solve in this assignment. If you don't, you're not going to get credit, even if you get the right answer, because you're not doing the intent of the assignment, which is all about matrices. So because solving by matrices does take a lot of time, I have several websites here to help you do this. So you can choose any one that you like. I like the one that I boxed here. That one I think is really nice. Desmos can also do matrices, and Symbol Lab. So I'm going to open up the one that I like and kind of show you guys what it looks like. So I like this one. Oh, why is it not showing up? Oh, probably because I just accidentally. There we go. Okay. I like this one because it has lots of different things that you can do. So for example, a row operation calculator. So let's say I want to have a matrix that is 3 by 3. And then you put in your numbers. So I'm going to just make things up. I have no idea. I'm just making this up. Okay, so you can go through the matrix process. So if I want to add 3 times the first row to the second, let's see, let's actually add 2 times the third row to the first row. So this is sort of like what we're doing with the Gaussian elimination. And I'm going to just click do it. And so now it tells me what my row looks like. So if you want to do this by hand, this is nice because you can tell it what to do and you don't have to worry about the math errors because it will do it for you. And then you can walk through and eat the solving by matrix process. So I like this row operation calculator. It's also nice because you can auto step it and it will automatically do one of the steps. And so you can see that it interchanged the first row and the second row. And that's because in our reduced echelon, or our row echelon form, as we talked about it, the second row has a 0 in that first spot. So they're trying to put it in row echelon form. And there's actually a button here to do that for you. And then it shows you all the steps to get there. And you can see my made up matrix has fractions. So if I go back, it has transforming a matrix to row echelon form. There's reduced row echelon form. It even has solving system of linear equations, calculating the inverse, calculating the determinant. You don't have to worry about any of these other things. It's just these sections here. And so what I would want you to do, say if you're going to solve a system using matrices, you would want to give me the matrix, and then you would give me the setup, and then you would give me the final answer, and then you would say what you did in between. Like, say, I used this tool to do this, so that I know that you used a calculator to do that, and you tell me which one you did. So that way, because I don't need you to have to go through all of this by hand. Technology is really great. I'm going to click on the Desmos one just because I love Desmos. Let me bring that back up. Whoops, wrong one. There we go. Ah, I have too many screens. There we go. Okay. So this is in beta, so that's the thing. It may not always work, but you click a matrix, rows and columns. So I'll do another 3 by 3 because most of our matrices are 3 by 3. Plug in your numbers. Again, I'm just making things up. Okay. But so if you want to find the determinant, you would hit determinant here, A, and then it gives you the determinant. But this kind of system is not really clear on how to use it to solve. But you can use it to get an inverse. So the inverse is that -1. So I can do, I think I need to put in the A first and then hit that button. And then it gives me the inverse, which is really nasty because I made this system up. But this calculator doesn't allow you to solve unless you are using the method of solving where you use inverses. So then you can do that. So this is a possibility, but it doesn't do everything. And there's a few others here that you can work around with, but just the kind of thing that I want to see for the setup. So let's say if you're multiplying matrices and you have to use the brackets. If you don't use brackets, you haven't written matrices. So if you're multiplying two matrices, you would do this times this, and then you can give me the answer. And you don't have to show the step in between. If you're solving matrices, you usually end up with something with like a line here. And then what you can do is just do an arrow and then give me the answer. And then just put a little note like used this tool. Just not tool. So you have to give me the setup, what you started with, and then you would give me your final answer. And so if you use that method, you would have 1, 1, 1, and then you would have numbers here, and then these would all be zeros. So you have to show me what you started with and then what you ended with, and then tell me what you used to solve. Because otherwise, even just showing all of the work for matrices is just a lot of work. It's just a very lengthy process, and if you were trying to type it up, it's even worse. So I recommend using these tools. So are there any questions on the tools or sort of the expectations for the application assignment? Okay. And actually, let's see, do I have the application assignment open? I have my email open. I can just switch to I can open up the class and show it to you guys. Okay, so you can see you're not given any of the systems. Be very careful. Number 1 here, it says you do not have to solve the system, so don't do extra work. I see people solving the system all the time. You don't need to do that. But you do need to give me the system and then write the matrix. Number 2 is matrix multiplication, so you'd have to write the matrix for this, show the matrix for this part, show the multiplication, and then give the answer, and it says interpret the result. A lot of people forget that, so you need to make sure you do that. 3, write a system of a linear equation. So you have to write the system first, then you write the matrix, and then B is actually the solving process. So you need to show the setup and then the final answer. And then the last one is another one that you have to give the system, and then you need to solve using matrices. So then you need to show the system in a matrix form, show the setup for solving, and then give the answer. So application assignment requirements. So I actually had the instructions for the not the application assignment, I was thinking about the journal. You guys know the application assignment requirements. Um, give me a single page. You can have it as a PDF or a picture or a Word document, but not a single page, a single file. Makes it, because I download these, and then if I have like 5 files I have to download, it's really difficult to keep track. This is where I was going for it. The week 3 reflection journal. So I updated the directions on the reflection journal because I saw a lot of people not doing what the directions said. So I thought, okay, clearly the instructions are not clear enough. So we updated them. So you need to document your problem solving process for each problem on the application assignment. So each question on the assignment, you're going to document your process of solving them. So I narrowed the amount of prompts to help you get started. What decisions had to be made when solving this problem? How many times did you try to solve the problem? How did you finally solve it? What method did you use to solve this problem and why? What additional resources did you use that may have helped? Where else could I clearly, when I was typing, I missed a lot of words. Where else could you find this type of problem solving? Wow, my brain was not fully there when I typed this up. So those are questions to get you started. You don't have to restrict yourself to that, but you do need to be reflecting on how you went about the application assignment, solving the questions, figuring out what you needed to do, that sort of thing. You need to submit this as a Word document so that I can leave feedback. If you do it as a text thing, I can't leave any feedback. So you need to do it as a Word document. And it needs to be 250 words minimum, so check your word count. And make sure you're actually reflecting on the application assignment. So this is not about the quiz. This is not about the material in general for the week. It's about the assignment itself and your process for that. So are there any questions? Does this help clarify what's expected for this? Okay. So, so moving on to the self-assessment. So, the self-assessment this week is 10 questions. So you have 4 attempts again. The highest score saved covers week 3 material. So that's starting to get, old hat now that you have 2 of them. They're kind of all in the same vein. So the suggested schedule for the week. I'm going to definitely need to zoom in on here. It's hard to try to squeeze it on one page. Okay, so I always like to have people take Wednesdays off just because, the week just started. So you can do a section a day, 8.1, 8.2, 8.3, 8.4, and then on Monday you can save all of those links and everything and then you can watch the videos. I did pick some review problems. This is probably more problems than you need, but I'm not expecting you to do these by hand, even in the review. Use the technology. So it's all about, can you set it up properly and then use the technology properly. So while there's like 16 problems here, with the technology, it should go fast. And then with 8.1, you can do the number 1 on the application assignment. 8.2, you can do number 2, and then with 8.3, you can do 3 and 4. You are not required to use anything from 8.4 for the application assignment, but you could if you wanted to. So that's how I've sort of made the schedule out to kind of help you go through it. Let's see, and my live session that I have scheduled, bringing up my calendar on my phone, I have scheduled it for tomorrow at 10 a.m. And I'm going to be going over 8.1, the matrices and systems of equations, basically making the connection from the system to the matrix and kind of introducing you to the whole idea altogether. So that's what the live session is going to be on tomorrow at 7. So do you guys have any questions anything that I have not addressed that you want to know? All right, that is a big nope. If you guys think of anything, let me know. If you want me to check over your work on the application assignment, and if you're like, did I show enough work? Because that's a common question: is did I show as much as I need to? You can send it to me, and then I can let you know. I can say, oh no, you need to show more work here, or I can even tell you if you're on the right track or not. So you are welcome to do that, to email it to me beforehand at what you want me to look over, and I'll take a quick look at it and see if you're on the right track, if you're doing what I'm expecting, that sort of thing. So all right, so I'm gonna pop off here and enjoy the rest of my night. I hope you guys enjoy the rest of your night, and hopefully I'll see you tomorrow night at 7. So all right, you guys have a great night.